Welcome guys, today I'm going to be proving that this massive number of 8 to the power of 23 plus 15 to the power of 23 is divisible by 23 using the methods of modular arithmetic. So essentially what this is saying is we have to prove the congruence 8 to the 23 plus 15 to the 23 is congruent to 0 mod 23, and we have to show that this is true. So it doesn't seem like we can split the modulo into more factors, because 23 is already a prime number. Which, I mean, on one side is good, but it does make things more straightforward. So usually in these situations we have to look at some special properties of numbers 8 and 15 in the mod 23 world. So maybe if we write out as the negative, 8 is congruent to 8 mod 23, so it's 23 minus 8. It's congruent to minus 15 mod 23. And also 15, it also seems to be congruent to minus 8 mod 23. Which is pretty interesting actually, but doesn't seem like we can use it much in the substitution. Like imagine we put minus 15 to the 23 plus minus 8 to the 23. We get the exact same thing, which is not very helpful. So this might take some creativity. But I think I see something interesting. Let's examine 8 squared. 8 squared is 64. And 64 is how much away from the next multiple of 23? Well, it seems like next multiple of 23 is 69. And 64 is 5 away from 69. So that's congruent to minus 5 mod 23. That's already much better. And what about 15 squared too? 15 squared, which is 225. And look at that beauty. 225 is also 5 away from the next multiple of 23. Next multiple of 23 is 230. 23 times 10. And 225 is 5 away from that. And 15 squared is also minus 5 mod 23. Now this seems also much more interesting than what we said up here, which does not really help us, by the way. But this can help us very much. Now if we substitute 8 squared and 15 squared into our congruence, then look what happens. We get 8 squared to the power of 11, right? That's 22, times 8 plus 15 squared to the power of 11 times 15. I didn't change anything. This is still 8 to the 23. It's just 8 squared to the power of 11, which is 8 to the 22, times another 8, 823. Same here. Didn't change anything. Just use some substitution. That's congruent to 0 mod 23 as we want to show. And 8 squared we know is now minus 5 in the world of mod 23. And so is 15 squared. And look what happens. We get minus 5 to the 11 times 8 plus minus 5 to the 11 times 15 is congruent to 0 mod 23. And we can factor out minus 5 to the 11 because we have the same thing in both sides of the sum. And if we do that, we get minus 5 to the 11 times, we have 8 here and 15 here, like we factor normally. 8 plus 15, that's congruent to minus 5 to the 11 times 8 plus 15, and that is 23. And that's congruent to 0 mod 23. And in fact, minus 5 to the 11 is an integer. Any integer times 23 must be divisible by 23. Any k times 23 is divisible by 23. Or not divides, I guess. Let's use that notation. Is congruent to 0 mod 23 for k in the set of integers. And like we have here, minus 5 times 23 is divisible by 23. And that is our proof finished. We have shown that this number, by decomposing it into smaller numbers and finding a 23 in there, that is in fact divisible by 23. Thanks for watching.